This is Intro to Proofs, section 6.5. We're doing activity 633, which will help us kind of think about how to find inverses of functions algebraically. So we're given this function f from the real numbers to the real numbers, defined by f of x equals 2x cubed minus 7. Okay, so sketch a graph of the function, and we do that in Desmos, but this is a pretty simple graph. So 1, 2, 3, 4, 5, 6, 7. It's going to go like that, and then go really steep there. Okay, so and I'll graph that in Desmos a little bit later, give you a much better view. This is really haphazard graph that I would not turn in for homework. So if you're turning in something for homework, you want maybe 3, 4 points, 5 points to be exactly on the money. So I'm just doing 1 point on the money. Of course, you want that one to be 1, and that point to be like down 1 and 1, and then maybe get 2 more on there to be actually like something you turn in. What you do to find the inverse of this is you say, well, let's set y equals 2x cubed minus 7. This actually just bring back memories of me teaching college algebra, which covers a lot of high school algebra 2 and pre-calc. So finding the inverse is you just solve for x. Some textbooks will have you swap the variables, so then you put like x equals 2y cubed minus 7. You don't have to do that. So we'll just solve for x. So y plus 7 equals 2x cubed. So y plus 7 over 2 equals x cubed. So then x equals the cube root of y plus 7 over 2. And that cube root extends down. Okay. And recall that with square roots, you can't take square roots of negative numbers, but with cube root, you can take cube root of negative numbers. So this is defined for all possible y's. So use the result to verify that each. All right, so then verify it. So if I plug in f of that number, the cube root of y plus 7 over 2, then I'm going to get 2 times the cube root of y plus 7 over 2 cubed minus 7. Okay, so then cube root and cube cancel out to get 2 times y plus 7 over 2 minus 7. Sorry, you couldn't see that last part there. So cube root and cubes cancel out to get y plus 7 over 2. 2 divided by 2 is 1, so y plus 7 minus 7 equals y. Okay, so I'm able to get any number just by plugging into that. So then existence of an inverse function. So, all right. So this is something you learned about in calculus, and you probably should have learned a little bit about pre-calc, hopefully. You learn about functions that are increasing or decreasing, and increasing or decreasing is called monotone. And so then, an increasing function, why is an increasing function always going to be 1 to 1? Well, an increasing function is always going to be 1 to 1 because think about the definition of 1 to 1. So the definition of 1 to 1 says if 2 things are not equal, then f takes them to 2 things that are not equal. And so if 2 things are not equal, one of them is lesser and one of them is bigger. And the function of increasing takes a bigger thing to a bigger number and the smaller thing to a smaller number. So they're not equal. Okay? That's the definition of a 1 to 1 function. Okay. So here, we can use a little bit of calculus. to show that now if you haven't had calculus, this class technically does not have calculus as a prereq. So, but there's some simple derivative stuff from calculus that hopefully you should have seen before. So if you have g from real numbers to real numbers, defined by g prime, no, defined by g of x equals x cubed plus x minus 5. If I take the derivative, you take the power down, so 3 comes down, and then the power changes by 1. And the same thing happens there, so plus 1, minus 5 becomes 0. Hey, this is always positive because x squared is non-negative, then f1 is always positive. So it's greater than 0, so it's increasing, so it's injective, so it has an inverse. Now, it has an inverse, but how do you find the inverse? That is a doozy of a question, okay? And one we're actually not going to be able to answer because algebraically it's just you just can't do it. You can't solve for x perfectly. And so there's times where we know an inverse exists, but we don't know exactly how to state it algebraically. That's really the purpose of this. It wasn't just like to beat you over the head with calculus. It was to show you that there's times we know a function has an inverse, but we don't know exactly what it is.